How is everybody? Yay, clap, there we go. Awesome. Let me start this off. Who here does not like flying? That's me. Anybody? You people all like flying? Okay, good. It's dark, I can see one or two hands. Who here does not like serverless? I mean, one of you submitted serverless as bullshit, so I mean, there's gotta be a few hands that are gonna go up here. No? Okay, you're the people that actually like serverless. Awesome. I know the term like inspires a ton of nerd rage and so forth, so again, my name is Tom McLaughlin. I'm from Serverless Ops. We're an AWS serverless infrastructure and DevOps transition advisory company. And what I'm here to present to you today is flying versus driving, myths, fears, and opportunity when going serverless. So I'm not here to tell you that serverless is like what you have to just like go out and do right now or anything like that. I'm really just here to present, the pros and cons of different arguments so you can weigh them accurately in your technical decisions. So how did I come up with this talk? I was sitting in an airport. I was in, I think it was like Detroit to be exact, and I was trying to come up with conference talks. And I was asking myself, like, what are the reasons I hear why people don't necessarily like serverless beyond the name? And there's the lack of control. Okay, what do I do when AWS has a problem? There's cost. Lambda compute comes at a premium. And there's a lack of freedom. You get what AWS gives you, and you have to use that. And I thought about all the reasons that I don't really like flying. I'm not comfortable putting, my safety in the hands of an airline or anything like that. Tickets are expensive, and driving means that, I got this freedom to leave whenever I want, and when I go flying, I'm kind of at like the tyranny of the airline schedule. So I decided to put a talk together that would cover these two sort of things. So what are we going to do? How are we going to do this? We're going to plan my trip to Denver. Okay, we're going to talk about how I got from Boston to Denver. There we go. Now, it's about, I think it's 2,000 miles and 30 hours from Boston to Denver. And a direct flight is about 4.5 hours. I love driving. I really don't like flying. Guess what? I didn't drive here. I flew. So let's start off talking about accidents and failures. We're not very good at judging risk or anything like that. This is, passenger deaths per billion miles for different modes of transportation. Again, I don't like flying. It doesn't make sense to me. And you're like, what, it doesn't make sense? It's like you're sitting in this metal tube that's going hundreds of miles per hour, and air is keeping you up. And yeah, air wasn't very useful keeping that up right now. Like, I understand the physics of it, but it's still just something I have to keep from obsessing about when I'm in the air. So, but if you look at this, you're like, well, there's, which you can't really see, but you look at like the rate of cars, okay? And then you look all the way down at the bottom, you look at planes. You're like, wait a second. Air travel is about 100 times safer than car travel. That, that pilot and and ground crew that I don't necessarily trust to get me from Boston to Denver, they're probably going to do a better, safer job at getting me there than I can actually do my own self. By the way, I have like an uncle that won't fly planes, but he will ride a motorcycle without a helmet, no problem. So let's talk about cloud accidents and failures, okay? Every time there is some major, AWS issue, people proudly, proclaim, this is why I run, all my own services. Who owns your availability? There we go. That's exactly right. And people tend to kind of ignore the times that like their self-hosted things have problems. So they go, S3, we can't use that. That's unreliable. Remember like a year ago when it had an issue? Let's keep running everything on this rickety SAN over here. All right? Sure, it has performance issues periodically. Every couple of months we've had some, we've had some service impacts, but we can't trust S3. No. Like rare catastrophic failures stick out in our brain. But if they happen often enough, you just accept it. It's just normal to you, okay? Like, I've come to this point in my engineering career where I think, I'm comfortable owning my own availability, by outsourcing a number of tasks to people that are actually better at doing it than me. So what are some of the issues I worry about when I have like an EC2 infrastructure? Are our services under or oversized? Are they horizontally, vertically, correctly sized? Do we have enough CPU, RAM, and disk? Is every single necessary host like running? You know when you log into a host and you find out that some service died 3 months ago? And you're just kind of like, oh, restart it, good. Nobody noticed. Are we up to date with our OS patching or anything like that? How about that syscontrol or config value? It's like, did we set that? Do we even know anymore why we actually set this value? And then, are we on the right version? I love this question. It's like, I think this bug was like fixed 2 releases ago. I'm not sure, maybe. So this is when, managing serverless infrastructure. Is the application responsive? Our application requests returned in a timely manner. Did we actually architect a platform that returns timely requests? Did we handle the dreaded AWS cold starts if those matter? What do our application error rates look like? And if we do have errors, can we gracefully recover from those? How do we handle our application traffic spikes? And we're looking not at individual services, but as the system as a whole. And how complex of a system have we built? If you thought like the jump from complexity of a monolith to microservices introduced complexity, the jump from microservices to nanoservices introduces a ton more. And I'll also add, some people also like kind of chafe at the limited configurability of their serverless systems. At the same time, it also like reduces the amount of things that you can actually break within your system. So here's some of the main takeaways about if you're thinking about accidents and failures when it comes to serverless. AWS is probably better at the undifferentiated low-level work than you are. Less control, again, means less things that you can actually break within your application or system. And this frees you to worry about issues that are actually higher up in your stack. You start down here and you're moving up this way. Now, let's move on to cost. Cost is a funny thing because, I don't know, I usually work for product companies and you start describing your product and you have this domain knowledge and you've developed this like product to solve these problems. And as you're describing your product, somebody like just raises their hand and goes, I could build that in a weekend. And before you can even like get your palm to your face, they follow up with, and I could build it for like 1/10 the cost that you're trying to charge. We're just gonna run it, we would just probably deploy a single T2 Nano, run the entire thing. It's like, all right, we're really bad at judging costs when it comes to our systems. Whoops. There we go. Okay, this is the cost of me getting from Boston to Denver. These were the prices last week. You can't really see them there. It's about $340 on the low end. That's if I want to take a 10-hour ride with a layover in between, or as much as $733 if I want to take a direct ride. I'm very cheap, okay? I'm okay with that. And I have this perfectly good mode of transportation. I have a car, and I've paid for it. My car costs $0. Let's hop in the Mustang because the drive from Boston to Denver costs $0. We know that's not right. Okay, so 2,000 miles at about 26 miles per gallon, $3 a gallon for premium, back and forth, it's $461 round trip, which doesn't really make my point. So we're gonna pretend I have a Honda Civic. And our Honda Civic's now going 36 miles per gallon, 266 because we're using regular unleaded, round trip, $296. Awesome. And yes, I did, alter reality so I could change the numbers to fit my narrative. Cast the first stone if you have not done that. Now, let's start talking about our AWS costs. So I spec this out at about an average of 1 request per second for an entire month, 100 millisecond duration, and 128 megs of RAM. Even in the serverless community, we're really guilty of giving you really terrible numbers about how much stuff costs. Okay? We're like, sure, you can run that, and it'll cost you 55 cents to run this entire service. That's against the 425 for that single T2 Nano. But we have to start talking about, the sort of, I don't want to call them hidden costs. They're just kind of the costs we forget about. Okay? They're just unaccounted for. So there's things like, well, we have our ticket, but I also need Lyft rides to and from the airport and home, and to and from the airport and my hotel. Now I've gone from like $340 to $426. That's a jump. Let's take my car, $296 for gas. I got a hotel stopover in Cleveland. I have a hotel stopover in Des Moines. I actually checked this out. Those were the 1/3 markers along the way. I got meals. I lowballed meals. I said, sure, I'm going to eat at the cheapest fast food place every single time. Not really. And coffee definitely lowballed that. And now I've gone to $448. Wow. That's a bit different. So let's actually start putting a single Lambda into production. We're going to start scaling the amount of traffic. We're actually popular, and people want to use our stuff. So, and more people want to use our stuff, the more we have to pay. Oh no, wrong slide. We're still at 1 request per second. AWS charges you twice for Lambda. Okay, it charges you once for the invocation and the amount of compute that you consume, so the duration and memory, and then it just charges you a fixed amount for every single time you ran. So you went from 55 cents to $1.09. Again, we're still at $1.09 at least. Your EC2 infrastructure, you might be running production services on a single T2 Nano. That's your problem. I don't work with you. But places I've worked, we have rules about how we actually operationalize things. We have rules about size. The smallest thing we will put into production is an M4 large. All right, it's a little bit more expensive than a T2 Nano. You have to put at least 2 of them in. Okay, if one dies, we need something that can actually pick up the load. Then we have our SaaS platforms that we use. We have logging, monitoring, and metrics. We have an agent for that, and we pay by the agent. There's a little bit. We have some more because we have a security vendor, and we pay by the agent. So we went from $425 to $186 and what is that? And 40 cents just to put a service into production. Okay. Moving along, you start scaling. We're becoming popular. Well, now we're up to 100, requests per second. We went from $1.09 to $109. Okay, that's a bit of a jump. And then we get into production. And here's what we find out in production. We're running actually faster we're actually running longer than 100 milliseconds most of the time. And AWS rounds you up to the next 100 milliseconds. So now everything is technically running twice as long. We started having these failures because of out of memory. And we said, you know what? We just have to we have to double the amount of memory. And now we're at $276.93 versus $186. So you're probably looking at me going, what the hell? It's like, yes, estimating this sort of cost is very hard and is very dependent on your workloads. Okay? There is no cut and dry answer to any of this. Some workloads will actually be cheaper, some workloads will be more expensive. Since I found it very annoying going through a lot of these price case studies, I went and talked to somebody who works at a company with a very large Lambda infrastructure. And they did the cost analysis both on paper and in production. And what they found was this. Lambda costs twice as much as running something on EC2. But before you go, oh man, why would I really want to do that? Over-provisioning, operational inefficiencies, other operational costs actually ate up most of that savings that they expected on paper. They actually got to the point where they were left with just this tiny sliver left of a cost savings. And they looked at that and then said, you know what? We're going to take that. We're going to take that extra that it costs to run on Lambda, and we're going to do this. So let's come to like the actual ride itself. All right, we're in production. This is what you can do when you drive. You can drive. You've seen all the PSAs about distracted driving. Forget the fact that I was taking pictures while driving on the highway. It's going to take me 3 days to get from Boston to Denver, and then 3 days back. That is 6 days of lost productivity and opportunity for me and serverless ops. Now look at what I can do on my flight. All right? There's a lot of stuff I could actually do. I can actually get some work done. That's a picture from my flight actually on the way here. The focus of my trip should not be how I actually got there, okay? It shouldn't be, how the heck did I get from Boston to Denver? It should be, let's enjoy DevOps days, right? That's why I'm actually coming here. I'm coming here to learn things. I'm coming here to talk and so forth. I don't want to think about, how do I get here? And my objective with engineering is to produce something that solves a problem and has value. It is not to engineer, okay? I'm very firm on that. Your objective as an engineer is not to engineer. It just happens that you use engineering to produce value and solve actual business problems. Coming back, taking a look at what some of my here's an EC2 infrastructure. I got a load balancer, front end auto scaling group, back end auto scaling group, and an RDS instance behind it. And here's a list of things that I have to worry about when I'm managing this. Now, let's turn this into a very simple serverless application. Those first three things, the host, app, and configuration management, cross that off. It's called CloudFormation. CloudFormation is not exactly perfect, but it works pretty damn well, okay? This is something that I know I can take and give to AWS, and I no longer have to manage. Our metrics. We started doing the DevOps, and we said, hey, we have all these metrics. We're busy down over here in the plumbing. You developers, you take care of all this stuff, all these things. It's possible, if we no longer have to start worrying about all this low-level stuff, for us to actually kind of take some of that metrics responsibility back. Let our developers, spend time producing features and so forth, and us making sure that things are running reliably. Our application patching. This is some of you folks do patch your application dependencies that I'm putting an application out into the world. Let's make sure the dependencies are patched. Many of you do not. You're very busy patching the latest CentOS vulnerability for some host that has no outside exposure, yet your core product goes out into the world with no testing. God only knows what AppSec issues are happening with it. Again, if you're not worrying about this low-level stuff, maybe we start moving up this way. And finally, we're going to scale entire systems now. We're not going to scale individual services. I'm not worried about scaling my front end, then my back end, and then my RDS instance, okay? Yeah, auto-scaling groups are great, but I have to still do all the platform automation so that hosts come up reliably. Now my job is to look at this. AWS is taking care of most of that scaling for me. I need to make sure that when we have a traffic spike, we get to that end, and that DynamoDB table is not being crushed anymore. And this is where I want to go. Notice everything I diagrammed before, all I did was focus on the technical pieces, okay? We never talk about the user, but the user is actually a part of your system, and you have to start actually thinking about them more. I want to focus on, did we ship something that users actually like? Does this feature result in growth? And ultimately, does this feature result in revenue for us? If I'm not busy trying to operate every single lever in the environment, I can start moving further and further up and focusing on these things that we haven't necessarily spent enough time on. See, on the left here, that's a Grafana dashboard. That's a generic Grafana dashboard you can probably find in any organization. And the metrics on the left, they determine my salary, metaphorically. This is a representation of how good of an engineer that I am, all right? But it's the metric right over here on the right. That's the one that actually pays my salary. And do you see that kind of disconnect there? I'm judged on one thing that doesn't actually generate, the revenue that actually pays me. Two companies can have exactly identical Grafana dashboards, and you can have one that has raving customers, and you can have one that has raging customers. I used to, many years back, I went to work for a business card company, okay? And when I got there, they said, we're not a business card company, we're a technology company. And I'm sitting there in orientation going, and then they explained it to me. By the end, I was kind of like, mind blown. Like, I get this. We're building technology to produce value and so forth. But fast forward like 6 years later, everybody's a technology company, okay? Your competitors, you're all technology companies. That's no longer a differentiator. Being a technology company in your space no longer makes you special. Focusing on like your core value and delivering something that people want, being the best damn business card company, that's an actual differentiator. And so we've gone from being a sort of company, going to being a tech company, and now coming back to our original mission and what we are. Now, yeah, that's actually intentional. I added this slide at the last moment yesterday, and I haven't had time to do a Google image search to just put something up here. So I'm just going to riff a little bit. I'm an operations engineer. I do not want to operate systems anymore. It's like, what? Wait, what do you mean you don't want to do that? That's your job. It's like, yeah, and it's fine if you do. Awesome. If you want to set up Vault, great. But to me, I look at it and go, AWS parameter store already exists. Now they got Secrets Manager. Awesome. Like, there's something that already exists that's very easy to use that solved my problem, which is just managing my secrets. And I started to think about how I picked up Puppet like 8 years ago. Hi, Puppet people. Hey. I was in a position where I was like, I don't want to configure servers anymore. I really don't like this part of my job. So, and people looked at me like, that's your job. It's like, no, I'm going to go down this pathway of infrastructure automation, and I'm going to try and alleviate this part of my job that I really don't like. And I did. And many years, few jobs, different environments, I finally got to this point where I built a pretty solid infrastructure from the lessons learned over many years. And I was like, this is awesome. I set out to achieve something. And I finally achieved it. There was a problem, though. I didn't know what to do for, in my career then. I don't like operating systems. What are the problems that are really left for me to solve within operations? And so I struggled for a while. And eventually I started playing with Lambda. I started playing with serverless, and it started to actually click on me. And I said, yeah, I don't want to do this work anymore. And now the tools and technology are coming around where maybe I won't be doing this work anymore several years from now. And just like, back in 2010, I did this technical leapfrog and tried to jump a few years ahead of everybody, I decided it's time to do this again. It's time to look and say, these are the things I don't really want to do. This is where I think I see things growing, and these are the new problems that I can start focusing on in my career. So I took this leap, and that's actually why I started serverless ops. I said, let me go out a few years and let me be here establishing, what is operations in this serverless world, so that when, technology catches up, we're prepared for this. And what I'm finding more and more is it's not necessarily developers that are driving serverless within organizations. They're very happy with their microservices and Docker containers. They're fine. What I'm finding is it's operations engineers that are looking around and asking themselves, do I want to keep doing this? I've been solving the same problems for 5, 6 years. Let's try something different. I want to thank you folks. This has been awesome. Any questions? Where's oh, there we go. Any questions? No? I'll let you because I can't really see.
What's your favorite open source serverless?
Oh, that's a bad question.
No, that's a good question.
Just like I don't believe in private cloud, I don't believe in private serverless. I think when you start, if you are not bound by organization, regulation, or any of that sort of stuff to stay on-prem and operate all that stuff, if you can operate in a public cloud, go public cloud. That's where much of your savings is. It's removing that operational work, handing it over to the public cloud provider, and so forth. So yeah, I'm OpenFAS, OpenWhisk, Nucleo. Those are the ones that I know, but they are. I generally don't spend too much time.
Any other questions? No? Okay. Well, please put your hands together for Tom.
Thank you.